Hello, welcome to section 4 of Unit 2. Today we'll be learning about the coordinate plane. This video is hosted by Iridium Tutoring. The coordinate plane. The coordinate plane is a two-dimensional plane formed by an x and a y axis. On this coordinate plane, we can see that the x-axis is the horizontal line or arrow, and the y-axis is a line going vertically. Points or coordinates on this plane are denoted using the notation x comma y, where x is the respective number on the x-axis and y is the respective number on the y-axis. And the point 0, 0, 0, 0 at the center is called the origin. Here we can see that whenever we put a coordinates into notation form, we always start at the origin or 0, 0. And we can see that here it's negative comma 6 because the x value, which is negative 6, is 6 points from the origin horizontally on the x value. And as you see 0 here on the y value, there's nothing going up or down. So therefore, the x-axis, x value is negative 6 and y value is 0. Therefore, the notation is negative 6 comma 0. Here we have 2 comma 5. We can see that here the x value goes 2 times over to the right, and therefore it's 2 is the x value, and y is 5 because we can see that it goes upwards or vertically upwards 5 times, which means it is 2 comma 5. And graphing lines will be discussed in the next few slides. Quadrants. A coordinate plane has 4 quadrants. They are Roman numerals and are called quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Here we see on the coordinate plane, the first quadrant is whatever point is in this box right here is part of quadrant 1. And here it's the top right of the coordinate plane. The top left of the coordinate plane is quadrant 2, and whatever point is in this quadrant is part of quadrant 2. The third quadrant is the bottom left here, and whatever point that comes into contact in this box is part of quadrant 3. And quadrant 4 is the bottom right, and whatever point is in this box is part of quadrant 4. So as you see here, quadrant 1 is located on the top right of the coordinate plane, quadrant 2 the top left, quadrant 3 the bottom left, and the quadrant 4 is the bottom right. Interesting graphs. As we explore further in the future, we will be able to graph lines on the coordinate plane using equations. However, we can graph more than just lines, and here are some cool and interesting graphs you can draw using equations on the coordinate plane. So here we can see that you can make many interesting things. You can make many different beautiful drawings just from putting coordinates on coordinate planes, as you see here. Graphing lines. When given an equation, we can plug values of x or y into the equation to make a table. So for example, we have y equals 3x. Here we can make a table. So this column is the x column, and here's the y column. We can see that here, what we did is using this equation, we either plugged in x or the y value in order to get the other value. So I mean, this means that whenever you plug, for example, you plug in negative 2 as x into this equation, you will get negative 6 as y to balance it out. So we put these into a table, and we can see that these will actually turn out as coordinates or points on the coordinate plane. So it is easier if you try putting balanced out numbers. For example, you have 2, 1, 0, negative 1, negative 2. If you have them around the origin, it will make it easier for you. So I'd recommend doing these numbers, negative 2, negative 1, 0, 1, and 2 as x values, because that's the horizontal line. So as you see, these are all corresponding to the x values based on this equation. So let me just give you an example. So here, we have -1. Okay. So y equals 3 times -1. This would equal, as we see, -3, because when you multiply these together, you get -3, and therefore the y value is -3. And it corresponds to -1 because we put in -1 as x value. So therefore, this is the x value, and this is the y value, as you see on the table. And once you have those down, oops, uh, you can see that you can put the um, values or coordinates onto the coordinate plane and make a line out of it. And that is the line in which stands for this equation. All right. Practice plotting. Okay. So fill out the table and plot the lines on the graph with the equation y equals 4x minus 3. Let's go over this. Let's try this one first. All right. So y equals 4x minus 3. So as we see, we just made a chart. You can make a chart by yourself too. And we plugged in the values for x, -2, -1, 0, 1, 2, as these are the simple ones that we can do. Make the line graphing easier. So we have x value. First off, we have x value -2. Let's plug this into the equation. Y equals 4 times -2 minus 3. Because you see x is -2 is replacing x because that's the value in which we want to put into the equation. So here we have -8 minus 3, and we get -11. So therefore, y equals -11 when x equals -2. So let's plug that in. Okay, so now we have -1 is x. So let's try that. So y equals 4 parentheses. As you see, this means just means multiplying. So if you see a number next to a parentheses number, you can just multiply them together to simplify it. Yep. So 4 times -1 minus 3 is equal to -4 minus 3, and that equals -7. So -7 is the value in which x is -1. So next we can do x equals 0. So y equals 4 times 0. Sorry about that. Minus 3 is equal to, we see 4 times 0 is 0, because when you multiply a whole number or a non-zero digit or any non-digit 0-digit number by 0, you get 0. So we have 0 minus 3 equals -3. So y value for 0 as x is -3. And as you see, we can see a pattern here, right? So we can see that this goes up by +4. We also see here it also goes up by +4. So this allows us to predict the next few points on the graph. So if we add 4 to -3, we would get 1. And if we add 4 again to 1, we get 5. And this allows us to find these points easier without doing all the mathematical equations, all that. So that's a good tip you can do if you see a pattern going on. Sometimes there is no pattern, but if you see a pattern, you can use this tactic. All right. So now that we have all of our points on the table, we can graph it now. All right. Let me just erase this real quick. All right. So now we can see that the x value here is -2 and the y value is -11. So as we said earlier, the x value is a horizontal line, and that y-axis is a vertical line. So we first start off with -2 as x. So first off, what we do is since it's -2, we can see these numbers on the graph. You can base our numbers on that. So since x is -2, we can move from the origin 0, 0. We move the imaginary point 2 times over to the left. So let's not put a point here yet. Let's just put it as a placeholder or mark. And then next we can see that the y value is -11. So this would go all the way down. So we would go 1, 2, 3, 4, 5, 6, so on. So that'd be all the way down here. Since this coordinate plane does not go all the way down to -11, we can just put it down here, just as a placeholder. And then we have -1, -7. So this would be -1 to the left of 1 over to left of 0, or the origin point. And let's pretend to mark it here. And then we go down -6, 7, because the y value is -7. So let's go down -7. So 1, 2, 3, 4, 5, 6. Again, this doesn't hold -7, so we can just put it here just as a placeholder. And then next we can see it's a 0 and -3. So as I was doing before, you just have to look at these across from each other. So the y value for that x value is across from each other. So this corresponds to this, and this, and so on. So that's how we find our coordinates. So here the x value is 0 and the y value is -3. So we move down -3 times below the origin point. So 1, 2, and 3. So -1, -2, and -3. Let me just check. Yeah. So that's 3 times below the origin point. Next, we have 1, 1, because you see when x is 1, y equals 1. So this time we move 1 over to the right because, as I said before, the quadrant 1 is always going to be positive numbers. So both x and y are positive. Quadrant 3, which is this bottom left corner, will always hold negative numbers. And then here, quadrant 2 holds the x value will always be negative and the y value will always be positive. And then this bottom right, lastly, the x value will always be positive and the y value will always be negative. So basically you're looking at here is whatever's left of the coordinate plane, the x will always be negative. If it's on the right, the x will always be positive, and as you see, if it's above the x, if the y value is above the x-axis, then it is positive. If it's below, it is negative. So once we've done that, we can see that 1 is the x value. So we move 1 over to the right because it's positive. And we move 1 above because it's y equals 1. And we can see that that is positive. So it's above the x-axis. So once we have that, we finish that. And lastly, we have 2, 5. So again, we can move 2 over to the right because it's positive, and 5 above the x-axis because it is positive too. So 1, 2, 3, 4, 5. And yeah, so now we have all the coordinates on the table put in. So then we can draw a line. So this might be straighter. You can use a ruler if you want. And you just draw this line down the coordinate plane. And that's the line. Sorry if this is not. This is usually just straight. It'd be better if you use a ruler, but this is fine. So this is the line in which y equals 4x minus 3 would look like. So that's how you plot an equation right here. All right. Now, why don't you guys go ahead and try plotting. So you can pause this video and try these out and fill them in. All right, hopefully you're done. Moving on. Number 3, let's try this too. All right. So hopefully you're done with that too. And these are the answers. Disregard the first one because we've done that with each other. These are the answers. Yeah. All right, so I'll just move this up a little bit so you can see. Yep. All right. And that's it. All right. I hope you enjoyed. Make sure to check out 2.5 for our next video. And thank you for coming.